Most of the lines in your CLAUDE.md are quietly making your coding agent worse, which means slower work and worse code. Bloated context files can run token bills into the thousands for output that you'll just have to fix. Hi, I'm Jack Stevenson, and I built SprigAgent to fix exactly that. It autonomously finds and proves which lines to cut, then asks before removing a single one. Context rot is a problem every coding agent faces. The instruction files you've written to steer them, Claude.md, GEMINI.md, and more, fill up with bloat, stale, redundant, low-value lines. And that bloat causes what researchers call context rot. Chroma tested 18 frontier models, Claude and Gemini included, and every one got worse as their context grew. And the clutter isn't passive. Irrelevant lines actively mislead the model, so the instructions you've written to help actively start to hurt. SprigAgent prunes these instruction files, never your code, and proves every cut is worth it before you approve. So context rot is a problem every coding agent faces, but it's also a problem an agent can solve. SprigAgent solves it by finding the bloat lines in your instruction files, and it cuts them out. It acts in a loop that decides whether each line is either load-bearing or just dead weight, and it keeps looping until a cut is proven safe or it keeps the rule. Now, why does that take an agent? Because you usually can't tell by reading whether a line matters. Two lines can look almost identical, and one is holding your whole workflow together. The only way to know is to test it. Pull the line, run the coding agent, and see if the work still holds. That's why SprigAgent is a meta agent, an agent that makes your other coding agents leaner. But how does this loop decide whether lines are worth cutting? What stops it from cutting something that matters? Well, the answer lays in the architecture. Here's the actual code. SprigAgent is 4 agents, built on Google's Agent Development Kit. And notice this line in the detector, a security checkpoint, wired in before the model. Every file it reads gets treated as untrusted input. Each agent has one specific role in the loop. The detector finds suspect lines, the rewriter proposes the smallest, safest edit, the eval runner proves that edit on real tasks, and the orchestrator makes the call. Accept a cut? That's proven. Retry with something gentler, or keep any rule if it can't prove. Let me show you a real run on the demo repo that ships within this project, a small TypeScript library with a messy Claude.md and 4 eval tasks. Those are real coding jobs, each paired with a test that checks the work. Before any model sees a word, the security checkpoint runs because these files are untrusted input. A rule-based pass with no model involved scrubs personal data and screens for prompt injection, and in this repo, it caught something, a planted injection attempt and a fake social security number. Both got blocked, and the data was redacted. Then, the detector flags its suspects. It's deliberately greedy, flagging anything that might be noise, and one of its flags is actually a load-bearing rule. That's fine, finding it is its job, and proving comes next. The detector marked this entire section over a single dead file reference, but the rewriter proposes removing just one dead line, and keeps the references that still work. Now the proof. SprigAgent runs the same coding agents on all 4 tasks twice, once with the rule and once without. In this demo, that agent is Gemini 2.5 Pro, called through Vertex AI. On the code style section, all 4 tasks still pass and the context drops from 631 to 411. That's 34.9% smaller. And here's the answer I promised you. That load-bearing rule, it tried the cut. Success dropped from 4 tasks out of the 4 down to 3, so it refused it. Rejected, load-bearing, it's keeping it. What's interesting is the model actually compensated a little without the rule, and it still wasn't safe to cut. That's what actual proving looks like. Every verdict lands on one dashboard, and nothing is applied until I decide. I approve the proven cut, and SprigAgent opens a pull request through the GitHub MCP server. It goes to a branch, never to main, and every removed line is quarantined, so if I'm ever wrong, nothing is lost. A quick word on the build. I wrote SprigAgent in Python with Claude Code inside the Antigravity IDE, and the agents run on Google's ADK. There are over 100 tests behind it, including one that proves your real repo is never touched. It even runs from inside a coding agent. Just type /sprigprune in Claude Code. And everything you just watched was a replay of a recorded run of the real model. That's on purpose. You can go ahead and clone this repo, run one command with no credentials, and every number you just saw reproduces on your own machine. One last thing, Anthropic's AutoDream prunes context too, but it guesses, and it applies its own cuts. SprigAgent proves every cut, and it never touches a line without your sign-off. Try the demo yourself, it's free, and when you want it on your own repos, the link is below. Follow the installation steps, set up your credentials, and start pruning, completely free and open source. Thanks for watching.